related to the first term in each binomial. So how is this term related to this term? X. How is x squared related to x? Well, it's just the square of x, right? So, I mean, this is kind of a silly question. It's one of these things, well, it is what it is, so I'm just going to kind of answer this. But the first term in the trinomial is the square of the first term in the binomial. Okay, so this is the square of x. This is the square of x. Okay, how is the last term in each trinomial related to the last term in each binomial? So how is the 9 related to the 3? The 25 related to the 5? Well, we see it's the square again, right? So the last term in the trinomial is the square of the last term in the binomial. Okay, all I'm saying is x is the square of x. X squared is x squared. 9 is 3 squared. 25 is 5 squared. Okay? You know, I don't even mind if you zone out here a little bit. This is only done once. It's to develop a formula. And then I'm going to give you the formula, and then all you'll need when you see this again is the formula. You're not going to have to rewrite this. This is just like where the formula comes from. Okay, I just can't spit formulas out and say use this formula if I don't explain where it comes from. But it's unlikely I'm going to ask you this again. Okay, the middle term, so it says, how is the middle term in each trinomial related to the middle term in each binomial? So it's asking, how is this term related to the middle term in the binomial? Okay. So the middle term in the trinomial is equal to double the product of the terms in the brackets. Well, that's pretty bad writing. Use FOIL to square. And again, I'm just showing this quickly. We're going to get a formula here at the end. But if we use FOIL to square a plus b and a minus b, so we're going to go a plus b, we're going to get a squared plus ab plus ba, which is the same. So I'll do it the slow way. Okay, now I have a squared plus BA and AB are the same thing. They're 2AB. Okay, so this is the formula that we are developing. Now that's for a plus b squared. A minus b squared is equal to, yeah.
2AB is greater than b squared.
Sorry?
Why is 2AB greater than
2AB.
Why is it greater than b squared? Or what does it come before?
Oh.
What comes first?
Just as a result of the way this FOIL works. I just left it in the same order. You're right, you could put b squared first, but for the purpose of our formula, it doesn't make sense. That's usually how they do it. They'll do all the variables first, and then they'll switch to the next variable that comes first. Like a squared, all of the a variants, b squared, all of the b variants. That's just the way they write it. But it's not wrong if you put the b's first. Okay, so now we get a squared. Now watch this. We get minus AB, and then we get minus, we get minus AB minus BA plus B squared. So we get A squared minus 2AB plus B squared. So therefore, we get this big deal here, the square of a sum. So A plus B squared is equal to A squared plus 2AB plus B squared. This is the big formula. This is the big revelation. And we use this in grade 12 all the time, believe it or not. In grade 11 as well, but all the way to grade 12, this comes up over and over again. How do you go from that to that? It happens a lot. All right, so let's use it in practice here. We don't have to write them out now anymore because we have our nifty formula, right? We're just going to say if it's plus, remember it's plus 2ab, and if it's minus 2ab, and on the ends are just each term squared. Okay, so maybe an easier way to do it is just square x, square the 3, and now in the middle, because it's a plus, I'm going to drop that plus down, and just 2 times 3x, right? AB, 3x, so we get 6x. That's it. Let's try it again. Okay, we have a binomial squared. I'm gonna give myself a little more space this time because that got messy. 4x squared on one side. I'm gonna write 10 squared on the other, so I get 100. Okay, and now in the middle, because this is a plus, that plus is gonna come down, so I'm gonna get plus. And then I just have to figure out what 2 times AB is. So basically 2 times 20x is 40x. Any questions? Find the square of each difference. Okay, here. We now have this equal to, who wants to try it? Alan, go. What am I going to write here?
X squared.
Good. What am I going to write all the way over here?
5 squared.
Yeah, what's that?
10.
Nope.
10 squared.
No. What's 5 squared? 5 times 5.
25.
Good. 25. Okay? I got my two end terms. You just need the middle term. Now the middle term, we know it's going to be negative because there's a negative there, so we'll put the negative there. Okay? We know this 25 is always going to be positive because it's a square. We know a square, negative times a negative is a square. This is always going to be positive. This sign's always going to be this. So now, Alan, the only thing you need to figure out is 2 times these combined. So what is this times this? X times 5?
5x.
Yeah, it's 5x. And then if you double it,
10x.
that's right. That's it. All right, Maxis, try this one. Okay, what am I going to write on the left here? Way on the left? You.
I don't know, I'm just trying to figure it out.
We have to write the square of 2b. So what's 2 squared? The b is squared, you're right. But what do you got to do with the 2 first? 2 squared is?
4?
Yeah, so 4b squared, right? Now, we got to deal with this one over here. This negative 7y. What is negative? What is, well, we know it's going to be plus because it's squared. So what is 7 squared?
49.
Right. And what do I do with the y?
You leave it there, or you want to do that?
What's y squared?
Oh, y squared is y cubed, or?
No, y squared is y squared, right? When you square y, you get y squared. Sorry, the language is confusing. But yeah, when I take y and you multiply it by y, what do you get?
You said y squared multiplied by y squared.
No, I didn't.
Oh.
I said, what is y squared?
Oh, what? If you square y, it's y squared.
That's right, yeah. Yeah, it's y squared. What is y squared? Y squared. It's like, what is 1 squared? It's 1. All right, what do I do next? I know this is going to be, what sign is this going to be, negative or positive? What? No, it's always this sign. You bring down the negative. So it's negative here. Now, 7 times 2. 14, yeah, and b and y. So it'll be 14 by times 2. So what's 14 times 2? 28 by. That was harder than I would have hoped. Slowing us down. Let's go, let's go, let's go. Let's see if we can finish. This is the last page. Expand and simplify using FOIL. So here we go. We know this is difference of squares, x squared. So we're going to go 3x minus 3x. They're gone, right? Plus 3x minus 3x. And then minus 9. So this just becomes x squared minus 9. Okay, this becomes 2.
Hi, Mr. Mills.
Hi.
Hi, it's Miss Queenie. Miss Angie and I are looking through our tech stuff that we have here in the library. Do you want more of those power cords for the laptops?
I think I'm okay.
Okay, can we just check them?
Yeah, I think so, yeah.
Thank you.
Yeah. Okay, this becomes minus 10a, and this becomes plus 10a, and this becomes minus 25. So we get okay. Okay, so I didn't do anything new there. I did the middle step, and what you saw is every time the two middle terms canceled out. Okay. Now I'm gonna skip all this. You can read it. It's online in the solutions. Okay. But basically, we're gonna come right down to what we need here. Right. This all proves these examples. You can see here from the question that the result is always the first term squared, the last term squared, and then that sign that's in the first bracket comes down. Or sorry, no, the sign is always, if one of them is negative, it's negative. See that? Negative, 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 negative. So what you get is this formula, difference of squares, also a formula you're going to use forever. When it's a plus b times a minus b, the result is just a squared minus b squared. Okay, we know that from this rule. This becomes a squared minus ab plus ab minus b squared. So these go away, you get a squared minus b squared. Okay? So it's even nicer when you have this happening because the formula is so simple. You just have to square the first term and square the second term and subtract them. That's it. So if I can explain this in simplest terms, when you have a binomial multiplied by the same looking binomial with opposite signs in the middle, that's called a difference of squares. So you can quickly answer that by squaring the first term and subtracting the square of the second term. That's it. Okay, square the first term, so we get 9x squared, and then we subtract the square of the second term, 4y squared. Oh, this one was a trick. Look what they did to us. they put the negative sign in the front, and then these two had the same positive sign. You can't have that, right? You need to rewrite this so it looks like this. See what I did there? Because of this negative sign, I rewrote them, but I put 2y in the front, and now we have the situation happening with a difference of signs. So we get the difference of squares, 4y squared, and then 9x squared minus. Who wants to try this one? Andrew, yeah.
It's going to be 9x squared.
Yep. Yep.
Y squared.
Yep, that's it. Okay, it says here, helpful hint. Many students keep using FOIL to find the square and sum of difference. You could do this. You could FOIL this and get the same answers. However, learning the new rules for these special cases will pay off in the future. I can't say that enough. Because you're going to be, as I said, using this all the time, and you need to start to just recognize it. If you see something's happening where it looks very similar and it's just separated by the signs, you know you can do this shortcut. All right? Last question. Maria's garden is square with sides of length x feet. Okay, so she has a square garden, so we'll draw it out. Nice square. Okay, and it tells us the sides are x. Next spring, she plans to make it rectangular by lengthening one side 5 feet and shortening the other side by 5 feet. So, what she's actually doing is she's going to... I don't know why anyone would do this, but x minus 5 and x plus 5. So she's taken away from her garden on one side and added to the garden on the other side. What polynomial represents the new area? So the area is the inside here. It's length times width. It's going to be x minus 5 times x plus 5. So Chenier, using the shortcut, what is this?
What is what?
What's the answer to this? We're multiplying these two. X minus 5 times x plus 5. No.
I'm so confused. Say that again, please.
Are you? You're just multiplying these two terms, right? We've just learned all about it up here. Okay? When we have two terms that are the same in each of the binomials, but separated by a different negative sign, we can jump to this. See that? So what would it be? First term squared is what?
X squared.
Yeah, x squared.
And
No. So if you're struggling with this, guys, you don't have to just try to guess here. You can work it out, right? Chenier, you could just do this. You could do FOIL, right? X squared minus 5x minus 5x. Sorry.
am I not squaring the 5s here?
Yeah, you are. Yeah.
So 25. 5 times 5.
Yeah. X squared minus 25. That's the right answer.
My bad.
That's okay. What polynomial represents the area? By how much will the area of the new garden differ from that of the old garden? So how much will it differ? So here's my old area, x squared. Here's my new area, x squared minus 25. So the new garden will differ by 25 feet. Okay? More questions? That's it.